On this worksheet, we're going to practice labeling galvanic cell diagrams based on a balanced redox reaction. To get started with this, it's really going to be helpful if we think about this overall reaction in terms of its half reaction. So the first thing that I'm going to do is divide this up into its half reactions. We have magnesium solid as one of our reactants, and then our other reactant is the lead 2 nitrate compound, but really I just want to think about the lead 2+ ion for now. So because that's really just kind of what we're being asked to label. So instead of writing out PbNO3 2, I just want to write out the Pb2+ ion part of this, and I'm not going to write the nitrate yet. I want to think about what's happening to the Mg solid. It looks like it's turning into magnesium nitrate. Again, I'm going to be ignoring the nitrate part of this. I just want to be focusing on the Mg2+ part. So our Mg solid is turning into Mg2+. That's going to be aqueous. And in order to do that, the magnesium needs to lose 2 of its electrons. So in order for it to go from neutral magnesium down to the Mg2+ cations, it has to lose 2 electrons for that to take place. The instructions, I did kind of skip over this, say that we want to assume that the electrons are flowing in this galvanic cell from the left side of the cell to the right side of the cell. We can already see that magnesium is the thing that is losing its electrons. So that means that in terms of this diagram, this is going to be our magnesium metal right here, and it's going to be losing its electrons through this wire over to the other side of the cell. As the magnesium loses its electrons and it becomes the Mg2+ ion, that gets dissolved down into this beaker of water, this aqueous solution right here. So we've already got 2 things figured out. Let's take a look at our lead. As you can probably start to guess, the lead 2+ ions are going to be picking up those electrons that are being lost by the magnesium. So the electrons are going to flow across this wire. They are going to be interacting with the Pb2+ ions that are down here in solution and plating the newly formed lead atoms onto the surface of this electrode. So this is what our diagram is going to look like. We're being asked to also label the position of the the location of the nitrates. The nitrates are everywhere. We've got nitrates with the NO3- ions. We have them with the lead, so they're on this side, and we also have them with the magnesium, so they're on this side as well. Last but not least, we're being asked to label the anode and the cathode, so here's our trick that's going to help us remember how to do that. First, we have the trick red cat. That reminds us that the reduction half reaction is taking place at the cathode. We also have the trick oil rig. Oil rig reminds us that the oxidation half reaction involves the loss of electrons and the reduction involves the gain of electrons. So if we can figure out which one is the reduction half reaction, then we'll also be able to figure out which one is the cathode. Reduction is gain. Who is gaining electrons? Looking at our 2 reactants, this is the gain of electrons. So this is our reduction, and this is taking place at the cathode. So we're going to label this guy the lead side. This is our cathode. And this is our oxidation. And the oxidation half reaction takes place at the anode. So we'll label this one. The magnesium is the anode. We've got one more that we can practice. Pretty similar thing. Here is our redox reaction, and here is our blank diagram, and we're just going to label the same type of stuff. First, let's think about the half reactions. We have 3 zinc solid, and they are being converted into zinc chloride, but really we just want to focus on the zinc. We're going to ignore the chloride part for now. So this is being converted into 3 zinc 2+ ions aqueous, and we're going to need to be spitting out some electrons in this process. In order for these 3 zinc atoms to be turned into cations, they're each going to have to lose 2 electrons. There are 3 of them total in this equation. 3 times 2 is 6 electrons being lost. This is an oxidation reaction. We can label that right now because electrons are being lost. This is going to be taking place at the anode. Since we know that electrons in this diagram are going to be flowing from the left side to the right side, we know that zinc is going to be on the left side, losing its electrons across the wire over to the other electrode. We can label this as the anode. We also know that the zinc 2+ ions, as they are formed, they are going to end up down here in this solution, aqueous. Our other half reaction, we're starting with 2 chromium ions, Cr3+. Again, I'm going to be focusing just on the chromium, ignoring the chloride ion. So you have 3 chromium ions, and those chromium ions are going to be picking up the 6 electrons that are being passed along this wire, and they will form 2 chromium atoms. Solid, I forgot the AQ right here. This is reduction. Reduction is gain. Our chromium ions, Cr3+ ions, are adding or gaining 6 electrons, so this is a reduction. This is going to be taking place at the cathode. So over here on this side, this is where we have our chromium metal. This is where we have our chromium 3+ ions. The electrons will come across this wire. They will come down on the outer surface of this electrode. The chromium ions are going to be attracted to the electrons on the electrode. This reaction will take place, and chromium atoms, as they are formed, are just going to plate on the outside of this electrode. This electrode, which we will label the cathode. And then last but not least, we're being asked to label the position of the chloride ions. Where are the chloride ions? They're with the chromium. They're also with the zinc. They're everywhere. So we have chlorides here, and we also have chlorides here, and these are aqueous.